Hello, Glendale Community College Chem 130 students. We are here to talk about Chapter 7, Chemical Bonding. Now, make sure you print off the shapes table and that you have it for this chapter. So this is either from Canvas or the website. And you can see we have a table here with some given information at the top. Now, you should have used this for Chapter 3. So we're going to use it again now for Chapter 7. So make sure you have this shapes table available. And as always, we're going to use the periodic table a lot in this chapter as well. So have those handy. All right, chemical bonding. We have learned that atoms want to be like the noble gases and that they want to be stable and happy with that S2P6 outer level configuration, meaning their goal is to have 8 outer valence electrons called the octet rule. S2P6, 2 plus 6 is 8. 8 valence electrons in their outermost energy level. The exception to this is hydrogen, which wants to be like helium. Helium, of course, only has 2 electrons, so it ends 1s2. So those break the octet rule. Now let's talk about metals. The metals on the left side of the table tend to lose electrons. Electrons go away. When you lose negativity, you become more positive. So metals tend to become positively charged cations. Now the nonmetals, there's not that many of them on the right side of the table, not the noble gases, they're already stable. But the other nonmetals, and hydrogen as well, can gain electrons and become negative anions. So nonmetals tend to gain electrons. They gain negativity, so they become negatively charged anions. Now, a metal and a nonmetal have opposite charges once they're ions. Pluses and minuses attract. Yeah, opposites attract. So metals and nonmetals tend to stick together, and we call this ionic bonding, and it makes an ionic compound. For example, who would be a good partner for calcium? Calcium is in column 2, the alkaline earth metals. So it becomes +2 when it's an ion. Now, ionic compounds have to add up to 0. So if calcium is +2, we need a -2 to go with it. Where are the -2 ions? Yeah, the oxygen column, right? The oxygen column has -2 charge when they're ions. So calcium and, say, sulfur make a good bonding pair. Ca is +2, S is -2. +2 -2 adds up to 0. Happy chemicals. What about Br? Who would Br bond with? Well, bromine is a halogen. It's in that 7th A column. And the ionic charge is -1. So we need a +1 to go with Br. Where are the +1s? Yeah, the first column, right? The first column are +1s. So something like potassium would go well with Br. So some examples of ionic chemicals are KCl and CaBr2. They each have a metal and a nonmetal. So that's what an ionic compound is. Now, what if we only have nonmetals? Well, they can actually bond with each other, but they don't lose or gain electrons. Instead, they share them. So nonmetals can share electrons with each other. A nonmetal compound is called covalent. Again, the nonmetals are on the right side, not the noble gases. They don't share electrons. But the other nonmetals, including hydrogen, is a nonmetal. So nonmetal compounds are called covalent. Guess what? All our diatomic elements are covalent. How do you remember your diatomic elements? Have no fear of ice cold beer, right? So HNOF, etc. Those are all diatomic. They have a little 2 subscript. Yeah, so they're bonded to themselves, and they're all nonmetals. So they are covalent compounds. Other covalent compounds would be water and carbon dioxide, CO2. Those are nonmetal compounds. So let's talk a little more about ionic compounds. I said one of them is CaBr2. Why is the formula CaBr2? Why is there one calcium and two Brs? Any ideas? Hint? Yeah, look at your table. Calcium is in the second column, so it's a +2. Bromine is a halogen in 7A column, so it's a -1. So Ca and Br would be +2 -1. That doesn't add up to 0. Ca is a +2, so we need 2 Brs to go with it. So 2 Brs would be -2 because they're -1 each. So the formula is CaBr2. So again, calcium is +2, Br is -1. We need 2 Br -1 ions to balance with the one calcium +2 ion. So +2 -1 -1 equals 0. Now you may have thought bromine is diatomic, and that's why it has a 2. Well, it's true, bromine is diatomic and it gets a 2, but that's only when it's alone. So bromine is diatomic when it's by itself, Br2. As soon as it bonds with another atom, the Brs break apart and bond with the other atoms. So the diatomic elements are not diatomic anymore once they bond to something else. So that's not the right answer. The correct answer is to think about their charges. That's going to become very important in chemistry class. The charges. So remember, we have to know the charges of our ions in order to do a lot of the chemistry coming up. Here's a list of compounds. I want you to tell me which are ionic and which are covalent. Remember, ionic is a metal and a nonmetal. Covalent is two nonmetals. So hit pause and look at these real quick. All right, so KBr is ionic. We have a metal and a nonmetal. Good job. SO3, covalent. It's a nonmetal compound. HCl may have tricked you. Hydrogen is over here with the metals, but it's a nonmetal. Hydrogen's a nonmetal. So HCl is covalent. Br2, covalent. Yeah, it's a nonmetal compound. CO2, it's also covalent. Yeah. And MgCl2, aha, we have a metal with a nonmetal, so that's ionic. So the ones with a metal and a nonmetal are ionic. So the first and last ones were ionic. It's a great place to pause, take a little break. Catch you later, GCC.